right. This meeting is being recorded. Okay. Put this on slideshow mode. Okay, I met Valeria at Valeria's pronunciation.
Yeah.
At Cascadia.js.
Yeah.
And then we recognized each other because we both work at the same co-working space. And so I was like, oh, what are you doing here? And she said, so I learned that she is an OSU student. And so I don't know, I got talking to her about capstone projects and like, I don't know, what I do. And she asked if I want to do something like this. So I just kind of said I would do it. But basically who I am is I am the CEO of well, basically the founder of a small software consulting business called Olio Apps. And we have like 12 people in total, including me and my business partner. And what I do is basically run multiple software projects all day and switch between different teams and just try to make sure that they're all going on the rails and you know, fielding calls for potential new projects and scoping those out and estimating those and just repeat. But I was wondering like who all of you are, if like where you're at in school. I guess Valeria, you're like senior. Is everybody a senior? Different levels? Okay. Are you all computer science students? Do you know what you want to do after you graduate? Something with AI?
I'd like to get into like, because I'm also into like audio engineering, so I kind of have this dream goal working with Sony to help develop games.
Nice.
I don't know what I'm going to do, but I'm actually not a song.
Something with computers.
Something with computers? Okay. Yeah, so anything in particular you would like to know or curious about? Or given that I run a software consulting company and like work with a bunch of junior developers.
I think I should have prepared them to bring their resumes.
I got a question here. In your experience in working as software consultant here, something you see like a bunch of different teams and projects things. What are some things you notice in some of your most successful teams versus some of your least successful teams?
Okay. Yeah, that's kind of what I'm going to talk about. Kind of dovetails with what we talked about, so that's good.
Curious about the process of keeping your clients happy. How realistic on time and on budget.
Okay, estimating and managing expectations.
Right. Yeah.
Okay.
Just because it seems hard. I don't know.
Yeah. Anything else? You mentioned like day to day, like what the day-to-day life is like.
Yeah. And I'm also interested in how you got started and why it's a passion of yours.
Okay. I'll start with that. I just like you guys, I was like doing computer science. I was actually doing business information systems as an undergrad, and my mom did a little stint tried her hand at recruiting, and I think I was her primary success. She got me a college internship at a company doing like IT. So I was basically like swapping out hard drives and fixing computers. And then this is like in 1999. So I also was in bands in high school and made my own website for my band. And then where I was working at, they were like, "Oh, you know how to do websites? You should work on our company intranet." And I was like, "Yeah, I want to do that." So I started doing that as well. And I kind of taught myself how to do basic programming. I was kind of a computer geek growing up, and so I taught myself how to like basically like they had a static web page of all of like the company phone directory, and I figured out how to like query the database from their help desk system to get like to make that a dynamic web page, because I was basically the one who had to update it. So I just basically like automated that process and made it so that it's always up to date. And then basically I did that, and I was basically getting paid almost minimum wage. And then I was like, now I know how to program. Do you want to pay me more money? And they're like, we can only give you like, I don't know, a really tiny raise. And so then I started looking, and I basically got another job where I doubled my salary. And I was like, okay, this is probably like a viable career option. And so in that job, it was actually for a company in Florida called ConnectWise, and they ended up selling it for like 1.5 billion recently. Probably the mistake I made was not just staying at ConnectWise the entire time, because I kind of helped them create some of their earlier software that ended up becoming like this big thing. They're like CRM, customer relationship management, Salesforce automation stuff for IT companies. But while I was doing that, I was working on their product, and then they also had this other side business where they would do web development for clients. And I was given a little bit of leeway, and given more leeway. So basically, I was just kind of running that side of the biz on a bunch of different projects. And then I was around 2004, 2005, I decided to try going out on my own. Anyway, I'm going way off topic. I'm just gonna like continue on. That's how I got started. All right, I want to talk about primary habits and skills, things that we teach, because I think this is good stuff for you guys to learn about, or like here. One thing is communication. It's kind of an obvious thing, but maybe not obvious. It's like 50% of the job. It's like 50% of the job, like your job is in our company anyway. And if you're a developer in any company, is being good at communication. Just assume things kind of fluffy. Like it's just as important as coding. And one thing, like we're all on Slack. I think you're all on Discord, but it's important to like push your status updates. And we kind of train this. It's like multiple times a day. Kind of use Slack as your stream of consciousness and say like what you're working on, what you're stuck on, how you think you're going to solve the problem, whatever. Because the earlier that you state that, then the sooner you can course correct to get onto the right path. Because there's chances are there's somebody else on your team who's done something similar before, and they can be like, oh, it sounds like good, or maybe you're 80% right, but they can help you get in the right direction sooner, instead of you just being radio silent all day, and then at the end of the day, you're like, here's the thing, what do you think? And you're like, should have talked about that earlier. It's like, not really the right way, not the right approach. Actually, we're thinking something way simpler, 3 lines of code. So anyway, it's just good to push your status updates. And also, if you're dealing with customers, especially, like grammar matters, and just for your peers to be able to read what you're talking about. It's just important to like have good, simple, clear, to the point communication. And for customer interaction, like you could email a client or something, upbeat, positive tone. I don't know, simple. Another thing is technical design. Does anybody know what technical design is? It's basically like in our company, it's basically like you have like some problem, maybe it's a feature you need to build, like you need to make the app be able to log in. I'm using the login example because that's like a clear thing that everybody understands, but it's probably something more complicated than that. And we do like a written Google Doc about this, where you just like identify, clearly state what the problem is, propose some concrete step-by-step plan to solve the problem, and then you're gonna read it and review it with the dev lead on the project, and like see it. Okay, does that make sense? Does that seem like we're going in the right direction or not? So, you know what stories are in terms of like agile development? Stories are like, sometimes they're stated in this like kind of weird English pattern, but like as a blank, in order to blank, I need to blank. So it's like for login, as a user, in order to view the dashboard, I need to log in. Or invitations. As an admin, in order to allow team members to access the dashboard, I need to be able to send them an invite to join. It's kind of like stating the purpose of why you're building the thing, and like also so that when you read it, you can be like, is the thing that I'm building actually going to accomplish what the thing that we need to do, or is it kind of going off on a tangent, or like nice to have, or is it accomplishing the feature? Another thing we teach is kind of like how to break up work. So if you're given the task of, or if we have a task of a login feature and building this with a team, potentially you can split the work apart so that one person could be doing some of it, another person could be doing some other aspect of it. You can both be working in parallel, and you can figure out, what things need to be done first. Like, for example, if you need to do login, you might need to do the design first, but maybe not. Maybe you could just do an ugly version of it first while someone makes the design, and then you can come back and make the pretty version, or like refine the UI once the design is finished. In the meantime, somebody could be working on the logic, which is like form validation, sending the credentials to the server, returning errors to the UI, or returning a token. Then there's like the backend side of it, which is like, let me receive the username and password, look that up in the database. If it's good, then send them back an access token, or if it's not good, send them back an error. So all those things could be done in separate. So like 3 or even more people could be working on this, and then by the end of the day, it could be done. Probably not a day, but a few days, you could all tackle that in parallel. How to focus on a task. I had notes on this, and I'm just gonna like escape from this view. So being able to focus on a task is like, be clear on what the objective is, and what is not the objective. So if like we're talking about, so for example, login, it might be, the objective might be like, let the user log in. The objective is not like make it pretty, or make it, make it 2-factor auth, or any other thing that it could be. And then do one thing at a time, like make changes in atomic units. So a lot of times you guys use Git, or like, so I don't know if you've ever used Git add dot, and that just like adds everything that you've changed anywhere as a commit. I try not to do that. I try to like just add the things that are specific to what I'm working on, and do things in individual atomic units. Even if you've got a bunch of changes, you can like just commit the stuff that is related to one thing together. Makes it easier to review. Also, like, initial junior mistake might be to like make a pull request that has comments, or things that are unrelated to what your work is, or commented out because you needed to get your testing to work or something like that. Oops, I left it in there. So I just like make a pull request, and then I self-review it and see like, did I leave anything in there? Oh yeah, I should take that out. Just like make it tightly focused, so it's just the thing related to the task. And then like be surgical, limiting blast radius. So that just means like, when I do this just by changing this one line, or just changing this couple lines, like, don't need to refactor the world in order to like make this work. Or like, some people might be like, I'm used to functional programming, not object oriented. This really should be functional. So while I'm in here, I'm going to make it functional, and just, don't do that. Especially not when you're just getting started on a project or something like that, because like everybody who else has worked on the project, they have that familiarity with how the project works. And if the feature is like, add this particular feature to it, it's not like change the paradigm of like how we do the programming. So it's just like make the least possible change, and be surgical. Like, just like if you were going to have surgery on you, you wouldn't want them to be like, oh, we just saw that, oh, you need a knee replacement too, so we just went ahead and did that. So try not to have the nice to haves. What else? Oh yeah, pull request workflow. So here you probably just get committing to master all the time, but in a team environment, you are often doing pull requests, and I have an example of one here. So this is a project that we just recently completed. I have it running as well. I'll show you an example. But this is basically like a really tiny one. We needed to fix the width on grid container items because if there was this placeholder icon, it was a different height than if the actual icon came in. So there's a point in the app where like some things are loaded and some things aren't. So like as things would load in, it would make jump around. So I wanted to make it like more polished and not jump around as things loaded. Be the same size placeholder or not. But here's an example of very tiny change here, and conversation. Get back to it. Please load. Okay. Here's where I said, like, I don't think we need this line of code to make, and it's also seeming to make the folder off center to the left. Can you remove it? It's a good catch. And your next line of next commit is basically like remove that. So that's like a super simple example of it, but it's just basically a conversation back and forth you have with your peers. Also super important is this the description. So we have kind of like a pattern that we want all of our pull requests to be. And that's basically like have a link to the issue. We have some issue for it, so we can like reference back to it. Describe what this is. So this is basically like fixes the width on each item. Media, which is like where you have a screenshot. It's basically this like teeing it up for the person who's going to be reviewing your work, make it like super quick and simple for them to review. And then verification steps. What does your reviewer need to do in order to like verify that the change you made actually accomplished the task or fix the bug? And so you write all this up, the other person can just look at this, and maybe they can just like, you've recorded a video like this is a video. You can see this is not a very exciting video. Yeah, there's an example where the icon came in and nothing jumped around. So, okay, that seems to be working. I can just hit merge on that. I don't have to do much more. What else am I going to talk about? Okay, here's where my slides end and my outline continues. Oh yeah. So I talked about some junior tendencies or some things like people who haven't done it for very long may come in with that we kind of have to try to train out or teach them a different way. It's kind of like what I was talking about before with like the radio silence until you have something and you're like, ta-da! Just hesitancy to show work until you think it's perfect. It's like, right to like, as soon as you have something, anything, you're getting just an idea, you like socialize that around or share it. Like, if you have work that's not done, like commit code that's like partially there, but at least you can like show like, this is the approach I'm planning to take. Then commit that and make a work in progress PR or a draft so that you can share it around and get some feedback early before you spend all day doing potentially the wrong approach. So it's good to like just share work in progress early. Code too fancy is just basically like, you know, I've heard of like this new programming paradigm. I want everything to be immutable and functional and all the things, and I'm going to just, or like I want to use TypeScript at all. TypeScript is a layer on top of JavaScript that adds strict typing. So like you declare this variable as a string, you can't assign a number to it anymore. It's more important as your projects get bigger and more people are working on it, because it's no longer small enough to just fit in one person's head. And there's like multiple areas of the code. It's like multiple cities. And so you need, so strict typing, like a TypeScript or a language like Java or Rust, kind of nails those things down so that you can't make mistakes. Can't make silly mistakes like, you know, assigning a number to a thing that you want to string, and it catches that early at the compile time instead of runtime. So you understand what that difference is. Compile is like when I can compile the code just before it's even running. I can do a bunch of checks. And you can also do linting, things like that. You can eliminate a whole class of errors by like getting things checked at compile time. Versus if the error is happening in runtime, that's like, oh, the app just blew up. And I can't find out that that's an error until the app blows up when I press the button. So better to catch things earlier. That was a tangent. Yeah, unrelated changes and bonuses. I already talked about that. I also asked one of our developers, Derek, what he learned in the past year and a half. So I just want to give you some of his perspective. Things that he like, I just like, give me your like 5 things you thought. So high level planning, we kind of talked about that. Things he's learned is like from building a complex piece of UI to implementing an API, everyday engineering work requires mitigation of complexity to planning and design. Sprint planning to design and conquer. So we usually build things in like 1 or 2 week sprints. And that's where we're just like, okay, the theme of this sprint is we're going to get the login screens working. Just keep using this example. So everything everybody's doing kind of going to align on that. And we're also going to divide and conquer. And we're going to estimate, smaller pieces of work are easier to estimate. Huge, well understood things are easier to estimate. If it's vague or there's questions, then that's risky. Try to like do more questioning and answering and de-risking it. It takes time at the start, but that saves time overall because it makes sure you're not do a sprint doing the wrong thing or the wrong priority thing. If you're building something for a startup, you may have like a grand vision, but they may need something to just get the MVP out the door. And so you need to boil down what is the most important thing to work on next, and what needs to wait until it's like that season or that phase of the company. We talked about technical design to identify abstract problems. Advanced soft skills, code review. I just showed a very simple example, but like learning to take and give positive, constructive feedback, like getting comments on your PRs is a good thing. It's not a bad thing. It's like, it's helping you. And it's also like learning to give feedback on other people's PRs and like not being afraid of like offending anybody. Like just like the more information we know, the better our product is going to be. Documentation. I use Notion a lot for just like self-journaling and stuff like that, but other people use different tools. And then in our code, we have like lots of readmes and run books, like how to deploy it, or how to compile it, how to download it and set it up for development. All those things need to be written down. So like, we may need to stop working on this project for 6 months and then come back to it and not have to like detective way or spend the first 2 days just like trying to inference how to get it working. Getting comfortable talking about code, talking about terminology and lexicon, doing things like this, giving talks and demos, talking to the client. Another thing that we use for communication a lot now is Loom videos. I don't know if you've heard of Loom, but it's like basically an app that you can install on your computer that lets you record a video with your screen. And then as soon as you hit stop, it gives you a link to it you can share with anyone. So it kind of like collapses the amount of steps you need to do to like make a video and share it. And so we use these a lot to just like demo a feature. Where it's like, you don't have to, someone can record the Loom video and it doesn't have to be the same time as like the other person is there available to watch the demo. They can watch it when they're ready. So it's like asynchronous communication with video. So this is an example of one. Persistence using login again. Check here. Search. Now, if I refresh the page and I try to go to the login page, redirect the portfolio, and notice S is up here. This is like the first letter of my name. Now, portfolio here. Work. My assets here. If I log out. Now I'm really logged out.
refresh this now so we can log into the portfolio. Also, I just want to point out a couple of things. Okay, spinner components, that's here. Full screen spinner, variants. It's like
This is a storybook, so you can use for atomic component development. So it's like kind of like separated from your app.
things here. Was drop down.
So you can just like show all the states of your components without having to,
What else?
without having to, actually step through all the, to show the spinner, I don't actually have to log into something. Just go to the spinner components. I can like try out all the different ways you can make a spinner spin, or all of its different styles. So we use that also for like kind of decoupling component work on different UI components from having to build the full app. So somebody could just work on that while the other thing is getting ready by somebody else. Any questions? So far? Okay. Any questions?
When you're splitting work models with people, and those chunks are gonna interface with each other, how do you ensure like that I'm going to connect well to whatever it's doing?
The technical design, because in the technical design, we like define the contract of like what his thing needs to output that your thing is going to consume. And so you know that he knows that he needs to like output this, and your thing needs to take this. So as long as you're doing that, he's doing that, then it should link up. Not always perfect, but like that's how.
So would that be, I think maybe we've learned it as information architecture and spec sheets, what you're describing. Is
Yeah.
that sort of like a umbrella term for those things combined together?
Yeah, information architecture and spec sheet. I don't know about what spec sheets is.
It's making sure the specs are right between you and the client.
Yeah, it's
and
basically
of
the
course,
same
like,
thing.
Going back and forth quite a lot for
Yeah.
data.
Also with clients, a lot of times our first thing that we do with them is like we call it a discovery. We basically spend a week just deep diving on what the problem is they're trying to solve and just like spitting it back to them, making a big write-up of like, this is what we understand that you said, and this is how we're planning to solve it. Does that sound right? And then we go back and forth on that. And we're like, that's pretty much right, but, and then we just do that for a week. Same thing with like internal tech design. But anything else? What else do I have? Anything else? I talked about some of this patterns, best practices, like make the simplest thing that can possibly work. Do simple first, complex later. So like first, just make the thing work. Don't try to make the full complex thing. If you can identify like a step phased approach where you can do a simple thing first and then add more complexity as you go on. It's much easier than trying to add the complexity and debug it. And it's not working. Small focus commits and PRs, doing one thing at a time, making changes in atomic units, being surgical, limiting your blast radius. Single responsibility principle, do you know what that is? It's like a kind of like a best practicey thing for just making sure like this thing is only, its only function is to hold the drink. It's not also like a radio transmitter or something like that. Even though it could be because it's metal. Just make it only do the thing. Journaling and rubber ducking is just like, a lot of times I'll use Notion or something like that if no one else is around and I'm like debugging a problem and it's a big problem and it's got like a lot of different aspects to it, and I'm just gonna like write in there as if I'm like talking to somebody else, and a lot of times you can figure out the problem by doing that. And also like if you, so I'm working on like a bunch of projects at once, a lot of times I have to put one down, focus on another one, and then reload the context back into my head again. And so if I have it all in the journal or a note doc for myself, I can like look at it and be like, oh yeah, that's what I was working on. And then I'm right back there instead of like having to like start from scratch. What is it? And that's part of context shifting, context switching. Pairing is good for just pair programming. You guys done any pair programming? Where you both sit. We do this over Zoom now. Also did it like for 3 hours yesterday and 2 hours this morning with somebody, just because we need to add this new admin role to the system. That's so we have full super admin that can do anything you want in the system, but then we have the admin users that can log into this admin dashboard UI, and they should be able to do stuff, but that user should not actually be able to do, carte blanche anything to the database. They should be able to read the activity log entries, but they shouldn't be able to nuke them, for example. So we needed to add this like intermediate admin role that let you do all the things that the admin console could do. Anyway, it was complicated, and so you do some pair programming. And also like doing like complex deployments sometimes. If it's like I need to deploy the database stuff and backend stuff, and you deploy the front end, and there's a bunch of different steps. Eventually, we try to automate that, but sometimes it's manual at the beginning of a project or too long in the project. And so a lot of times we just do those deployments together. So we kind of catch each other's mistakes and like, all right, I'm gonna do this. Is there anything else? And like, oh yeah, first you need to run this. So we just do those things together. Now I'm just gonna show you a couple examples. This is one we're still working on right now. It's pretty cool. Carbon Title is a platform for decarbonizing buildings, or like building developers. They want to claim that their buildings are carbon neutral, because these days that's a good selling point for your commercial space or your residential space. It's becoming more important to reduce your carbon footprint. So this is a platform which does let building developers input their buildings and either get a calculation or supply their own calculation. If some people commission studies because they built a big building like the one we're in, and the developer will commission a study called an LCA, and I forget what the acronym stands for, but if you have that, then you can just input your information. Otherwise, you can add a building in here and use the carbon calculator. And if you do things like say how many floors are above grade, and each one is like 30,000 feet, and there's one floor below grade, and it's 10,000 feet, and it's a university, but actually it's a mixed use, and half of it is also a fitness center. And see the OSU campus. This is just test data. Did you have a question?
Is this like
I think so, yes. We actually worked with a guy who's doing his PhD in this, and he wrote this giant spreadsheet calculator, and we kind of like reverse engineered that spreadsheet calculator and built it into the back end of this app. So let me just do a little bit more to show you. Let me do an actual address. It's got like Google Maps integration. I don't know where that is, but yeah, sure. And then you can say, oh, this is wood frame construction or steel frame, reinforced. And as you start to put in information, like it's already done a calculation here. It's like 22,800. This is tons of carbon emitted. And part of this is embodied. This is like, that's what's like built into the structure at the time of building it. And then operational is just like ongoing, like the AC and the electric. And then once you do that, you can add your building to the portfolio. And what that's actually doing is it's like got this integration with blockchain. So all of the records are put onto like a public carbon friendly blockchain that so it's like this public ledger that anybody can see. It's like outside of the carbon title itself, but it's on the public blockchain. And then so once you get your buildings in there, next thing is you get carbon credits. And so these are different example projects, but there's different people that do like a reforestation project, and you can purchase, they sell you the credits for that you can then apply to your buildings. So you can purchase credits and then apply them to your buildings here. So this is an example of like, this is a building and it has these many credits remaining, and then you can say like I've purchased 100 credits and I can apply them, like 50 of them to the embodied credits of the embodied carbon that's being emitted by this building. And that way you can kind of like make a plan and have a way of like tracking your carbon usage down to the end. That's an example of one of our customers in one project. Another more simple one is this Columbia Acura. They make robots for putting packages on pallets in factories. And so they wanted to build an app for trade shows for their like sales reps to have all the videos and media PDFs to show potential prospects. And one of the requirements is they need to work completely offline. So they need to have access to all these videos and stuff, but even if they didn't have access to the internet. And so we figured out that you can't really use a web app to do that because you can only have like maximum of like 500 megabytes or something, or some limit or to cache it offline. So we needed to build a native iPad app. So we use a React Native to build this app. And then, so this has got videos. Say one. I have no idea what this is yet. Size of a bag. Let's try to find one with a robot or something. Here we go. And then this runs in it also has all their PDFs, their spec sheets and things like that. And this goes in landscape mode. And then I didn't actually have a functional iPad, but I went out and bought one to make sure that the app worked. So now I'm enjoying my new iPad and watching robot videos. And so we just built this in like 5 weeks because they're going to the trade show like this weekend, starting Sunday. And so we've been doing that. And also we talked about how do we get something like how do we ensure success or like hold to our estimates, things like that. So for this project, we basically set up like a weekly call with them every Wednesday at 9 a.m. And we start delivering it right away. From first we had this app and it was basically just doing nothing except like hello world. And then you could log in, or actually you couldn't log in, but you could see a grid of junk like this on the homepage. And then it was like, and then by the next week we had like the breadcrumbs going where as you navigated where you could see like I'm drilling in and then get back out. And then by the next week, you could see the videos playing, whatever, PDFs. And by the next week, you could search. And so every week we would do a little bit more. And it's like, like, I can't believe you got that going in 5 weeks. Because there's actually a rescue project where there's another developer that was on the project, and they actually got sick and they couldn't work on it anymore. So they contacted us and they asked us if like we would be able to do it, and they're like, yeah. That's how it happened. So that's a couple examples, different projects. Any other questions or?
Curiosity question here. What is in your whole computer science? What is one project that you particularly fondly remember?
Well, these two that I just showed you have been pretty fun. I moved to Oregon. I used to live in Florida and I moved to Oregon, and I was working for a company in Florida called WeoGeo, which was a startup, and they wanted to be out on the West Coast to be like closer to like startup land, Silicon Valley and stuff like that. So we ended up moving to Portland, and we worked in the Portland State Business Accelerator building for 2 years, and that was building a mapping marketplace. So they would do like flyovers for scientific data with like scientific instruments, and do like infrared picture mapping to do things like, measure the water quality of this lake or something like that, and different science mapping. They have like these big data sets. And it was at the very beginning of AWS, so we were like, and we got in on like early beta of AWS, so like early beta users of EC2 and S3 for storing our images and doing processing on it. And so that was really fun. And I went to the RailsConf in Ruby on RailsConf in Portland in 2008, and actually got to give a talk where it was like half me, half the guy from Amazon. It was like we were giving our use case and how we were doing it, and how we made our own like EC2 auto scaling thing. It was like, as usage builds up, we'll like run more instances, and as it stops, we'll stop them. And then the AWS guy. And so I was like, get to co-present with the Amazon guy. So that was pretty fun. So yeah, you never know what you're gonna get into.
So do you try and study in a main tech stack with your team?
Oh yeah, I didn't talk about tech stack, except for that app is React Native, but we typically do React and TypeScript on the front end. Partially because like that's the most popular thing that most people know, and it's like the thing that most people are looking for. So if you're going to do front end development, I would learn that first, because you can do that not just for web development, but for native development, desktop apps. You can pretty much build an app for any platform using React these days. And then on the back end, now we're using a lot of Node and TypeScript on the back end, because then it's just one language, and everybody, if you've learned JavaScript on the front end, then it's not too huge of a leap for you to do JavaScript on the back end too. Postgres, SQL, MySQL, serverless framework. We do some Golang too.
So you have some junior developers on the team, and I assume that you are part of the hiring process.
Yeah.
Where do you go first for finding a new hire, and what do you look for when you read their resume or when you sit in an interview with them? What are some things that we can be working on?
Yeah. So the communication skills, but anyway, to go back to like where I go first is, so we were everybody used to be based in Portland, but I recently moved to Bend. But everybody is now remote. We had an office in downtown Portland. Now we actually do have a co-working space here in Bend, and there in Portland central office. And we worked with a couple different code schools there. Epicodus and Alchemy Code Labs, and also we've hired people from like PSU, and we have a guy now who has a master's in computer science. I forget which university he's from, University of Wisconsin or something like that. But doing stuff like this, and so for Epicodus, what we would do is they would give us like a batch of candidates' resumes, and then we would set like 8 interviews with 8 different people, and then we just interview all of them in like a day or two, and giving them all the same interview, and then 4 of us would be in on the interview. So first part of the interview is basically like just getting to know you. We do some like workplace scenario questions, like tell me about a time you had some misunderstanding or it's a problem and how you handled it. I can't remember exactly now what the questions are, but typical like workplace scenario questions. And then we do talk about your knowledge of tech. So we'll talk about like, what is your understanding of the internet? So if I hit go on the address bar in the web browser, what happens? And what do you know about, what's your strongest language? Okay, tell me about that language. How do you, like, what's your skill rating in that language? And then hopefully it's a language that we also know about, and then we can kind of like interrogate a little bit on that. And then we do things about like, do you know about React? Do you know about things in our tech stack, and then we do a coding challenge, which is a fairly simple thing. Should be something that you should be able to do in like 15 or 20 minutes. It's basically like fairly simple algorithm. Given this input, give me this output, and use us as Google. You can't actually Google, but you can use us as Google, and we can talk through it. And use this as a resource as if we were like a senior dev on the team, and just talk through your problem. And you see if like, do they actually talk through it? Can they write syntax correctly? Do they have like, where are they at and like how good they are in coding? Do they remember syntax off the top of their head? If they can't even remember that, then we're like, they probably have a lot of training to do. But if like some people will just be like, oh, okay, and then they start doing it, or they first. What I really like to see is if someone pseudocodes it out, and like so like say, well, first I'm going to iterate through the array, and then I'm going to like look for the ones that start with the character watches, such or whatever, things like that. And so how they talk about the problem, or how they think and break down a problem. And then we also look at the email communication. Like, did they show up on time for the Zoom call or whatever? Are they communicating quickly, or how well is that part going? Those kinds of things.
That's cool. That's many different layers of soft skills and life skills.
Yeah, you're trying to, because it's a very narrow time frame before you have to commit to like, okay, I'm gonna bring this person on. That's a risk, because like if they're not good, that's takes a lot of time. It takes a lot of time and effort, especially once you're in and we invest a lot into like training all of these other things that we didn't learn yet. So. All good?
That was excellent. Thank you so much. Really appreciate you taking the time.
Yeah, that's fun.
That's really big. On the other side. Some more exposure, but